Good morning, Randall Postiglione for Joliet Montessori. It is April 23rd, 2020. We are still in lockdown. I'm videotaping, from my living room. This is number 13, video number 13. Today, we've kind of put aside quadratics for a while. Next week we'll do graphing quadratic equations. But I thought we would just take a little break from quadratics. Something I haven't talked to you about. We have been using math symbols all year, but never really talked about the origins of math symbols. I'm looking over at my shelf here, and I have an Egyptian statue. Okay, this is probably a king. I forgot who this was, but anyway, we're going to talk a little bit about Egyptian mathematics today, okay? And Egyptians, the numbers that we use are Arabic. So on the sheets that I sent you, if you watch the videos, those YouTube videos that I sent you, they may talk about Arabic numbers. They're the numbers that we use, 1, 2, 3, 4, 5, as opposed to Roman numerals. You know what Roman numerals look like, right? Well, even before Roman numerals, there were hieroglyphics. Okay, hiero means sacred, glyphics means picture. You put them together, you've got these sacred pictures. Okay, well, they also use them for numbers. Okay, and if you watch that video, I really hope that you did, because it's going to be really hard to do those worksheets. If actually, I think I gave you a number 14, a content check. It's going to be really hard to do those if you don't watch the videos. But today, I thought we would talk a little bit about how this math works, this ancient Egyptian math works. First of all, you're going to hear this word non-positional. You know what, before we get into non-positional, why don't you pause and write this down into your notes, okay? All right, hope you got that. The title is Math and Symbols. Students will be able to add, subtract, multiply, and divide using ancient Egyptian hieroglyphics. Okay, so when we have the number 123, this is positional. We've got 3 units. We have 2 in the tens place, okay, and 1 in the hundredths place. This is base 10. Okay, notice those were all multiples of 10, right? Okay, if I showed you this, these would be different numbers, right? 123 is one number, 132 is another number. If I switch the digits, remember we know the difference between digits and numbers. If I switch the digits, I get a whole new number, okay, which is larger. Okay, in the Egyptian hieroglyphics, on the other hand, if I have 1 here, okay, and a 10 there, and that's a rope, right? That symbolizes 100. And let's go to a lotus flower, okay? Okay, these could be in any order, okay, any position, okay? These are non-positional. Okay, so this is a 1. I'm going to put a 1 here. Okay, this is a 10. I'm going to put a 10 here. I got a 100 over here, and the lotus is 1,000, so I got 1,111. Okay, 1,111. Okay, now if I had another 10 over there, I'm sorry, another 100, this would be 1,211. If I had another lotus flower, okay, this would now give me, okay, 2,000. All right, so these hieroglyphics can be in different positions, okay, but a good ancient Egyptian mathematician knows it doesn't matter where they are, okay, because he or she knew that this was a 1, this designated a 1, these are tens, hundreds, thousands, okay, you got 10,000s. If you watch that video, you'll see, oh gosh, there's a million with an Egyptian holding his hands up like this. Whoa, you know, he's sitting down. Okay, that's a million. But anyway, take a look at that, the video, and I think I even included them in the content check. I gave you 1, 2, 3, 4, 5, 6, 7. I'm sorry, ones, tens, hundreds, thousands, 10,000s, 100,000s, and millions. Okay, so non-positional, hieroglyphics. Okay, the next thing I want to talk to you about is, now remember, the ancient Egyptians, they wouldn't be using Arabic numbers, they would be using hieroglyphics, okay, or hieroglyphs, all right? There's something called Egyptian doubling. Egyptian doubling. Okay, I've got some examples here I want to show you. Let's say we want to multiply 27 times 32. Okay, I gave you a link to a YouTube video. There's a professor on there that's doing these. I thought I'd give you another example. All right, on the left, I'm going to put numbers underneath here, okay? You know 2 times 5 or 5 times 2 is going to give you the same answer. The same thing here. You could have the 32 here and the 27 here, okay? That doesn't matter. But what does matter is, on this side, we're going to go with the binary numbers. Binary numbers are 1, 2, 4, 8, 16, and so on. Okay, it depends on how big the numbers are. Okay, I stopped at 16 because I know I can make the number 27 with one or more of these numbers, okay, added together. Now over here, and here's where the doubling comes in. Over here I'm going to write 32, and then I'm going to double 64, 128, 256, and 512. Okay, so I took the 32 and just kept doubling. All right, now here's the cool part. I'm going to make 27 over here. Okay, now, well, I know that 16 is going to have to be part of that. okay, because 16 is the biggest number, and I got to get up to 27. If I add 8 to the 16, I'm already up to 24, so I need 3 more. 4 is not going to do it. But 2 and 1, that's 3. That's going to bring up my 24 to 27, and now I have numbers adding up to 27, okay? I'm going to draw arrows to the right, okay? And these numbers, 32, 64, 256, and 512, once I add those, okay, and you can add them in your head, or you could add them on a separate sheet of paper, go to a calculator, I don't care. But this is going to be 864. Okay. If you check this, 27 times 32, you're going to get 864. Very cool. Okay? That's how an ancient Egyptian mathematician, okay, would multiply numbers. Okay? Because when you think about it, and we've said this before, multiplication is just a shortcut of addition, right? Well, we're adding here. We're doing a lot of adding. What's really cool about this is these numbers over here mimic how computers talk to each other. If we want to write this in binary, this would be 1 1 0 1 1. Electricity, electricity, off, electricity, electricity. Okay, so 11011 would be the binary form, okay, of 27. Okay, all right, next. I'm rushing here, I'm trying to fit all this in. What if we have division? Okay, before I get into that, I want you to write these notes down. For multiplying, okay, remember these steps. Just write down these steps. You've got the binary numbers on left. Okay, that's these guys here, right? Okay, so write that down. You can always pause your computer. Okay, and then secondly, you add the numbers on the left. Okay, you add these to equal the divisor. Okay, I'm sorry. To equal that multiplier or factor. Okay? All right, so this is multiplication. I made a mistake. I said divisor. That's when we talk about division, we'll talk about divisor and dividend. Okay, so write these down. That will help you. It's really easy to confuse division and multiplication. Okay. All right, next. Division. I'm trying to rush this, sorry. If you have any questions, just email me, okay? All right, what if we were dividing 722 divided by 19? Now notice I put the dividend on the left, the divisor on the right. Okay, once again, the first step is binary numbers on left. Okay? All right, 1, 2, 4, 8. You'll get good at this. 16, 32, right? Okay, let's see. Over here, I start with 19, and I'm just going down. 38, 76. I'm just doubling. 152, 304, and 608. Okay? Doubling. All right. Basically, I mean, if you see it, what you're doing is you're doing stuff in reverse here. I'm going to add these numbers up to get to that number, 722. 608, that brings me pretty close to 722. But if I go to 304, I'm over. I'm 912. That's bigger. 152 even. If I go 152 plus 608, that's going to give me a number bigger than 722. So I've got to go to 76 and then 38. Okay, I'm rushing this. I'm sorry, but you can check this. Go with arrows to my left, okay? And this is going to give me my answer. 32 plus 12, 38. Okay, and I think I made a mistake here. That's 2 up here, and this is 4 here. So it's 32 plus 6, sorry. Okay, so 722 divided by 19 is 38. You can check that on your calculator. The first step, once again, is to put the binary numbers on the left. Step 2 is divisor on right. Okay, there's the divisor. And then number 3, you add numbers, okay, on right to equal dividend. Okay? These number here equals 722. Okay, boy, I rushed that. I'm sorry, but I was trying to squeeze it into just one YouTube video. Hope all is well with you and your family. Once again, if you have any questions about these, just let me know. Have fun with this. It's pretty cool. I love teaching Egyptian math. If we had time, we would get into the geometry, making pyramids and measuring them and talking about the history another time. Okay, take care.